Your Docker image for an API that returns hello world weighs 1.2 gigabytes. It's a whale hauling an entire ocean just to carry one glass of water. Your build takes 12 minutes. Your teammates takes 12 seconds. Exact same code. And the worst part, the container that runs perfectly on your laptop dies in production. Here's the uncomfortable part. Docker isn't broken. Docker is doing exactly what it's supposed to do. The problem is you. Well, the problem is what you were taught. Because there are 4 patterns that every production SRE team actually uses. 4 patterns that take that 1.2 gigabytes down to 80 megabytes, and those 12 minutes down to 12 seconds. And not one of those 4 is in the official Docker tutorial. Not one. We're gonna fix all 4. But first, you need to see the original sin, the mistake almost everyone makes on the very first line. This is the Dockerfile you copied from the tutorial. You recognize it. You probably wrote it yourself. It works. It builds. It runs. And it's completely wrong. Not because of what it does, but because of what you think it's doing. You read this like a recipe. Step 1 through 6, top to bottom. But Docker doesn't read a recipe. Docker builds a graph. Every line is a layer. Every layer is a node. And each node has a state. It's either cached or it's invalidated. And here's the rule the tutorial never told you. When one node gets invalidated, every node after it gets invalidated too, in a cascade. That one idea, the cascade, is why your builds take 12 minutes. That one idea is why your image is 1.2 gigabytes. The order of the lines isn't cosmetic. The order is the performance. The order is the money. And once you see the cascade, the 4 patterns that fix both problems become obvious. Let's start with the most expensive mistake. Pattern 1. Look at your original Docker file again. What's actually inside that 1.2 gigabyte image when it lands in production? The TypeScript compiler, the build tools, the 700 dev dependencies, all of NPM, your uncompiled source code, Git, the tests, the README, all of it shipped to production. Your production server needs none of that. It needs Node and the dist folder. That's it. But in a single stage Docker file, everything you used to build stays inside what you deploy. So you have to separate the workshop from the display case. That's a multi-stage build. Here's how a real production team does it. 3 stages. This line is the key to everything. Copy. From build, the runtime stage starts clean and copies in only the dist folder from the build stage. The compiler, the dev dependencies, the source, the tests, all of that lives in the earlier stages. And the earlier stages never get deployed. They get thrown away. The test stage runs your tests during the build itself. If they fail, the image doesn't build. You can't ship broken code by accident. The build is the quality gate. Same functional result as your original Docker file, a fraction of the size. And notice we're using Node 22 Slim here, not the full image, but Slim still ships a shell, a package manager, things your production server will never touch. We haven't gone far enough yet. That's pattern 3. Pattern 2. Remember the clocks? 12 minutes versus 12 seconds. Here's why. Remember the cascade. When a node is invalidated, everything after it goes down with it. Now look at these 2 lines from your original Docker file. You copy your entire project first, then you install dependencies, but copy grabs every single file in your repo. So you change 1 comma in one source file and that node is invalidated. And in a cascade, the npm install right after it is invalidated too. You reinstall hundreds of dependencies because you changed a comma. 12 minutes, every single time. The fix is understanding what changes a lot and what barely changes. Your code changes 100 times a day. Your package JSON changes maybe once a week. So the thing that barely changes goes first. You copy only package.json first. You install. That layer is now cached. And since package.json didn't change, that node stays green. Docker reuses the entire install. Only then do you copy your code. Now you change the code and the graph only rebuilds from that line downward. The dependencies stay cached. 12 seconds, 2 lines swapped, 60 times faster. And you didn't write a single new line of code. You just understood the graph. Pattern 3. Now we go after that 1.2 gigabytes head on. Where does all that weight come from? From the very first line. Node 22 isn't Node. It's a full Debian distribution with Node sitting on top of it. It ships a shell, a package manager, curl, bash, system utilities, libraries your app will never touch. To run a server, that's malpractice. And there's something worse than the size. Every one of those tools is attack surface. A shell inside your production container is a tool an attacker can use. So here's what serious teams reach for. Distroless. Images that contain your runtime and absolutely nothing else. No shell. No package manager. No bash. You build with the heavy image, like always. But the runtime starts from gcr.io, Distroless, Node.js22, Debian 13. And look at the CMD. It doesn't say node, it says distserver.js directly. The Distroless node image already sets node as the entry point, so your CMD only needs the path to the file. No shell needed. There isn't one anyway. From 1.2 gigabytes down to roughly 150 megabytes. Same app. And if your production dependencies are lean, hello world scale, you can push that down toward 80. Either way, you just cut the image by a factor of 6 or more. And what if your app is a static binary? Go Rust, compiled C? Then you don't even need a runtime. You go one step further. From scratch. The empty image. 0 bytes of base. Your final image is exactly your binary and nothing else. Not megabytes. Kilobytes of overhead. 3 patterns. You already have an image that's small, secure, and reproducible. What's left is making the build genuinely fast. Pattern 4. Pattern 4. We fixed the layer order, and npm CI is now cached between builds. But there's one case that breaks that cache anyway. When you actually do change package.json, you add one dependency and Docker downloads everything from scratch all over again. But npm already keeps a local cache on disk in @npm. The problem is that cache lives inside a layer, and when the layer is invalidated, the cache goes down with it. You throw the cache away at the exact moment you need it most. The fix is mounting a cache that survives between builds, outside the layer graph entirely. That's a BuildKit cache mount. 2 things. At the very top, syntax Dockerfile. Chap 1. That turns on the modern BuildKit syntax. Yes, it's a comment, and yes, it matters. And in the run, you mount a persistent cache at root.npm, which is npm's cache folder. That cache is not part of the image. It's not a layer. It lives in the BuildKit daemon and persists between builds. So invalidate npm CI all you want. The packages you already downloaded get reused straight from the mount. BuildKit has been the default engine since Docker Engine 23, so on any remotely modern setup, you're already using it. If you're running something ancient, you can force it with Docker BuildKit 1. But you almost certainly don't need to. You change one dependency, and now you only pull what's new. The rest comes from the mount instead of the network. The first build pays the cost. Every build after it flies. 4 patterns, 80 megabyte image, build in seconds, no attack surface, persistent cache. This is what actually runs in production, which brings us back to the question from the very beginning. 4 patterns that change everything, and 0 of them are in the official Docker tutorial. Why? It's not incompetence. It's not a conspiracy. It's incentives. The official tutorial has exactly one job. Get your first container running in 5 minutes. Get you to say, wow, it worked, and stick around. That's adoption. And for that goal, a Dockerfile that boots in 5 minutes is exactly right. It's the shortest thing that runs. But optimizing your first 5 minutes and optimizing your next 5 years are opposite goals. The tutorial optimized for adoption. You inherited the debt, and I'll be honest with you because otherwise this just sounds like a sermon. I shipped that junior Dockerfile for years, the single stage one. The copy, before the install. I put it into production, into real systems, with real users. Not because I was stupid, because it worked. And when something works, you stop asking whether it's right. That's the trap. The difference between a junior and a senior is almost never what you don't know how to do. It's what you think you already know, and never went back to question. Distroless, multi-stage cache mounts, none of that is advanced Docker knowledge. It's just what happens when you stop reading the Dockerfile like a recipe and start reading it for what it actually is. A graph of decisions where every line has a cost and an order that matters. So no, you don't have a problem with Docker. You don't have a Docker problem. You have a Docker tutorial problem. And if that made you a little uncomfortable, good. Because Docker isn't the only place the tutorial handed you the junior path. The most dangerous one is a command you run several times a day without thinking. Before you run it next time, there are 5 questions a senior asks and a junior never does. The same questions that separate someone who copies a command from someone who actually understands what that command does to their system. That's the next video.